Hello, my name is Rick Durham. I'm from the North American Advanced Analytics channel team. Today I'd like to talk with you about IBM SPSS Predictive Analytics products. Today in the world, in order to succeed, we need to see better outcomes. And better outcomes are based upon smarter decisions, which are based upon actionable insights that are based upon relevant information. Predictive analytics offers unique insights into how to answer those tough business questions. Unique insights that help answer business questions like, how do I reduce my customer turnover and retain my most loyal customers to maximize profitability? Which factors are most likely to drive customers to choose my service versus the competitors? And which customers are likely to respond to my offers, and which channels will generate the best responses? The ability to capture, predict, and act are key to this process. So in terms of capturing information, we want to use data collection, which is a surveying tool, our native data source connectors, our databases and data warehouses, and grab accurate views of the customer's attitudes by combining what we know in the enterprise and the social media space. We want to take this information that we've collected, this data, and we want to be able to predict. And predictive capabilities bring repeatability to the ongoing decision making and drive confidence in the results and decisions. Understanding these customers' micro behavior across channels, uniquely understanding the customer to predict their next move and to make the best offer is really key to how the predictive part of this works. And then acting on those predictions is very important. Unique deployment technologies and methodologies that we have maximize the impact of predictive and descriptive analytics across your business, within the business processes, and across multiple platforms. So to give some idea of the basic suite of IBM products, we can take a look at this slide. And what we see here at the top is typically when we're talking about predictive analytics, we're really focusing on one of three areas. We're talking about predictive customer analytics. In other words, how do we acquire, how do we grow, how do we retain customers? We're talking about predictive operational analytics. How do we manage, maintain, and maximize something? In the case of predictive maintenance, we're looking at how do we minimize our costs and maximize our revenue by minimizing the downtime of our equipment, or maximizing the actual workforce to put the best people on the most difficult problems within the enterprise. And then predictive threat and fraud analytics really deal with how do we monitor, detect, and control fraud. To support these three broad use cases, in the next row, we see data collection, social media analytics, statistics, modeler, and decision management. And these are all the working tools of SPSS Predictive Analytics. So data collection is used for surveying. Social media analytics is used to go out into the social media space to grab key data that exists in that space, to perform natural language processing on that, and then to build predictive models with that. Statistics is all about looking at forming hypothesis and testing those hypotheses. It's the classic tool that's used for that type of testing, ANOVA, regression, correlation type testing. Modeler is used to build predictive analytic models. We're going to see some examples of that later in the demo here. And then decision management is used to be able to take what is known in terms of business rules that exist in the business, put those with the predictive models and any other data that is brought in the data collection, and to be able to automatically and optimally make decisions out into the operational systems. Underneath all of supporting these set of applications is collaboration and deployment services, or what we call C&DS. And collaboration and deployment services is a software suite that allows us to store models, store statistical predictive analytic models. It allows us to be able to version those models, allows us to do embed real-time prediction into the applications, and do batch processing. It's sort of a utility that can glue that holds these things together from an enterprise standpoint. And then below that are the basic software components that make up these tools. So we use Cognos software, Infosphere, Maximo. Of course, we have Nectisa as an enterprise data store appliance, and WebSphere and WebSphere portals to be able to expose this out in the intranets inside of a company. And behind really all of this is IBM Research, and which is a huge investment from IBM's perspective to reach ahead 10 years ahead and be able to give our customers and our partners the latest and the greatest technology that exists. So I want to talk a little bit about Spss Statistics briefly. Spss Statistics is an advanced statistics and data management for analysts researching business problems type tool. Again, to repeat what I said, it's useful in terms of the analyst that is taking a look at data that came in, forms a hypothesis. Maybe that hypothesis is, is fertilizer A better than fertilizer B, or do customer group A respond better than customer group B with a particular ad or advertisement, clinical trials, those type of things. It's very, very useful in terms of advanced analysts, but also just researching general business problems. Spss Modeler, which we're going to see in this demo, is our predictive intelligence, predictive analytics tool. It is a workbench with data preparation functions to build analytic streams or jobs that run in real time or execute in terms of a batch job. It's a set of algorithms or methods that allow us to go through and really look for patterns that exist in the data, and then to be able to store those patterns and bring new data in and be able to score that, or be able to look at insights that are contained in that new data. Spss Text Analytics, and we're going to look at an example of this, which is part of Modeler in the Spss Modeler Premium tool, uses natural language processing to develop heuristic rules and statistical techniques to reveal the conceptual meaning of data. It allows us to extract concepts from this data and categorize them. It allows us to take unstructured data, which is about 80% to 90% of the data that most organizations have, and take that qualitative data and make it more quantifiable and actually use it in models. And what this then does for us is enable the key discovery of insights from sources such as surveys, documents, emails, call center notes, web pages, blogs, forums, can be maintenance logs, and even more. Spss Decision Management, as I spoke before, a set of tools that allow us to automate high-volume decision-making enterprise-wide. It injects powerful predictive analytic models and business rules into core business processes. So in this scenario, we're no longer depending on humans to look at data on dashboards collectively and make a decision and then interact back in the operational environment. Decision management is doing that function for us. And it extends the predictive insights into the business user at the point of decision in real time. So it means that the person who's the customer service rep or the adjudicator at an insurance agency simply is able to look at a screen and see automatically, what's going on and the automatic decisions that are being made. Collaboration deployments services, as I spoke before, is this flexible foundation for managing and deploying analytics throughout the organization. People who are producing models, these people can share them, can secure them, and then deploy those in real time or in batch mode. So at this point, I'd like to do a demonstration of Modeler to show you a little bit about what I've been talking about. So this is the interface to Modeler. And what we see here is the standard set of Windows menus that we see with most applications, and the standard type of drop-down menus. And we see this white design canvas here. And this is where we're going to be doing most of our work. In Modeler, the way it works is that we have a set of nodes, and basically these are elements, data mining nodes that we can drag and drop out onto this design surface, and we can connect these together. So I want to build a really simple model here, show you how to do this process. But before I do, I want to talk a little bit about the various nodes that exist here and how we use those. So we have our sources node, which allows us to pick from data sources that would include databases, flat files, fixed files, statistics files. You can pull data from TM1. We can pull data from Cognos, SAS files, Excel, and so forth. We have a records operation set of nodes that allow us to take the data that we pulled, and we can do selects on that just like SQL queries. We can sample it, we can sort it, we can do distincts on it, we can aggregate that. About any kind of record operation that you can do in SQL, you can do with the record operations, as well as merging operations. So we can pull data from multiple sources, merge those together, provided they have a common type of key, or we can append data. Do field operations, so at the column level we can perform operations to do filtering or to create new fields, for example, derived. We can bin the data, we can reclassify the data, partition it. In addition, we can also do automatic data prep. So part of what the designers of Spss Modeler have done is to include sort of this data scientist, encapsulate the features, and the functionality of a good data scientist in terms of building models and preparing data for those models. And that's what this node basically does for it. So it'll go through and remove nulls and blanks and do transformations on the data that it knows that are needed for the downstream modeling. We have a set of graphing nodes that allow us to plot our data, basically anywhere along our stream, and I'm going to develop what that really means in a second. Anywhere along the way we can, basically tap into the stream, take a look and see what our data looks like at any point along that. We have the modeling nodes, which include about every method or what we call algorithms to be able to build models with. I would point out here that we have an auto classifier, auto numeric, and auto cluster node. Simply put, if we know we got a classification problem, but we don't know which algorithm would be best, we can choose one of these. Again, the data scientist functionality is inside there. It will test every one of the models against our data set and pick the best model, basically the best method and the best algorithm to use to build that model. We can take and output our data to tables. We can do analysis, data audits on that. We have a variety of means of outputting into Modeler, as well as exporting that data. So this is basically a mirror reflection of whatever we can do with, on the input side and the sources side. Basically, we do the same thing on the export. So we can export out to a database, to a flat file, back out to TM1, back out to Cognos, and so forth. And then we can pull data in from in statistical models that we've built in Spss Statistics into Modeler and use those. We can also do text analytics, and I'm going to demonstrate a little bit of that functionality here. But essentially means we can pull our unstructured data into Modeler, be able to build models with that. And we can also create custom nodes if we'd like to. So let's go through and build a simple stream here so I can show you how Modeler basically works. So in this case, we're going to choose a variable file source. And when we double click on this, it will open up and allow us to edit it. We can click here and we'll pick our file. In this case, it's a census CSV file. We can preview the data that's in this file. And from that, I can see that what I've got is the age, the working class, education level, marital status, occupation, relationship in the family, race, gender, hours they work per week in their native country. And then I get an idea of their income level. Is somebody going to make greater than $50,000 a year, or somebody going to make less than $50,000 a year? So I will choose this as my data source. I'll apply. And my next step will be to put a type node here so that I can tell downstream from here the actual method that I'm going to use, what to expect in terms of the data. So I connect these two nodes together using my F2 key. And essentially right there, I build a stream. And I'm going to take the type node here. We're going to use all of the inputs. The role for every one of these columns will be as an input. But the income level, we're going to change its role and make it a target. We'll click Apply, click OK. And then for the model, I'm going to pick a C5 as the method, since I know that I've tested already the auto classifier and found out that it's the best method to use for this type of data. And then I will run this. So basically, it runs. The output of running this method, the C5 method, is this modeling node here, this income level node. And this is called the model Nugget. It is the model. And it's basically a database that gets produced with patterns in it from the data that came from the census CSV file. So when we open up this income level Nugget, what we see is this. We see that it has predicted for us. First, it's told us about the predictor importance. So these were the fields that we brought in, marital status, age, and so forth. And we can see that if you're going to predict somebody's income level, the strongest factor, at least from this census data set's perspective, is marital status. And it follows by age, and then income level, and then the amount of hours they work per week. And over on this pane, we can see that as we break down sort of this hierarchy of rules that were found, we can get an idea of what rules would take place in order to make this prediction. So one of the streams of this model is that if somebody's age is over 27 and their education level is greater than 12, and their marital status is they're married with AF spouse, that they're likely to make greater than 50K per year. But we see here that if this person spouse is absent, that using sort of the same rules path, they're likely to make less than 50K. So essentially, this model helps build a set of rules that we can understand in terms of who's going to make more than 50,000 or less than 50,000, and what's really driving that. This is important, as we said earlier, in trying to figure out, if I'm selling a luxury item, knowing and being able to predict just on a few things if a person makes more or less than a certain amount of money may give me a very good idea whether they would purchase the luxury item. Finally, we said that we need to be able to do this on the individual level. So we need to get this down so that it's actually a prediction for that particular person. And we can see that occurs by adding a table node to this stream. And when we execute this table node, what we see here is we see that we have the original, so we knew this historically that this person made less than 50,000. But where you see the $C income level here, this is showing us the prediction that the model made, and it's giving us a confidence value for that prediction. So essentially it's saying that we believe that there's an 80.4% confidence that this person will make less than $50,000 per year. So again, we get not only the prediction, we also get the confidence for that prediction. So I want to take a look at a little more sophisticated model here. And in this model, what we're looking at is, even though this has more elements to it, I want to roughly divide this between using structured data and then using unstructured data. And I'll talk more about that in a second. But what we're doing here is we're bringing in data from a set of customers, and I'll open this up, we'll preview it. And what we see is, we see here, in this case, this is telecommunications data. So we've got an ID. We know the person's gender, their status, how many children they have, their income, if they own a car or not, their usage of the telecommunications phone, their age, rate plan, long-distance usage, international calls, the local calls, drop calls, and so forth. What we're trying to predict here is, are they going to churn or are they going to stay with us? So anyone that's canceled obviously churns. The people who are current are still with us. In the telecommunications business, where you have people moving from one carrier to another, we're really talking about thousands and millions of customers, being able to predict if somebody's going to leave or not is very important, because you can then offer them incentives to keep them to stay. So essentially, we built the same type of model that you saw in the stream that I built earlier, but instead this is a churn model. So we're not trying to predict whether someone is going to make greater or less than 50,000. We're trying to predict, are they going to leave or not, right? Leave our telecommunications company. So I want to run this table and show you what the output looks like here. I'm not going to go back through every one of the elements there. I want to show you the output of this. And you can see that bringing this data through the model, we see that they've either canceled. This was their historic value that we had stored for them. But here's our predicted value. And again, there's the confidence for that value. The other thing that I want to show here is I want to show you from an overall perspective of how good is this model. We can run this analysis node. And what this shows us that compared to what we knew historically about each of these records, so historically we may have known that that person churned, and we made a prediction that they're likely to churn. And therefore, our prediction matches historically what we knew about that customer. So in the case of this model, the structured model, meaning this data came from a database or an Excel file. It's not free-form text. We're about 90.1% accurate. This stream below here, I want to walk through it. But what we're doing here is we're doing some text analytics. So what we've got is for the customers that we talked about in the top stream up here, we have a set of comments from these customers. And essentially what we see is, here are the kind of comments. Does not like the way the phone works. It's difficult to compare to his last phone. Or wants to know how to do text messaging. So we could get these comments from a call center where people own phones, call in and discuss the problems or the issues that they're having with their phone, or maybe just ask questions. What we do with this is in SPSS, we're bringing this data in and we're putting it through what's called a text analytics node. In the text analytics node, what it will do is it will basically parse through, use natural language processing through those comments and create a set of flags. That's what I want to show you here, and then I want to show you how we use those flags and how this improves the model performance. So when we run this node, what we see is that same output that I discussed before. So we see the same demographic information, but we've actually added the comments to that. And when we look at this, what we see is this. The natural language processing of text analytics has went through this text, for example, said his battery has never worked well, wants a new phone as soon as possible. We see that it extracted a set of flags out of there and set a flag for this category battery. So in other words, it found the term and it actually put it in a category called battery and set that flag to true. Why this is important is because now we could not use this unstructured text in the model, but we can use the structured text, or we can use these flags in a model. And by including those in the model to predict churn, this is the result of what we see. We're going to compare our model churn with text and our model churn, this model without text. So our unstructured model, or structured model that we built here. When we run this, we get for our model with where we were using text analytics to create those true and false flags, we get a model that is 92.13% accurate overall. Comparing that to the structured model, the first one that I showed, we have a model that's 90.34%. So this 2% increase in accuracy of the model, that is where we're using the text analytics, can amount to millions of dollars for a company where 2%, keeping 2% of your customers, when you're talking about millions of customers, is a big deal. And being able to predict those customers that will churn from that large data set is a big deal. So why IBM SPSS? Why choose it? IBM is a leader in predictive analytics. We've been a market leader for 40 years in predictive analytics technology. We have a broad product range, goes from statistics all the way through the deployment product families with analytic decision management and other leading edge products. We're a first to market deployment methodology. We have the best deployment of predictive models and statistics models out into applications that organizations use of any vendor that's on the market. We provide this incremental phased approach to the enterprise solution. It's based on the convergence of analytics, architecture, and business processes. We play well with others. Non-intrusive integration with service-oriented architecture. We're database agnostic. That is, we can connect to Oracle, SQL Server, DB2. You pick the database, we can connect to it. And we leverage most organizations, their operational software and IT investments. We have the highest return on investment, which was 94% achieved a positive ROI in 10.7 months. And this was from a Nucleus study that was done. So, IBM is a leader in this area. I'd like to thank you for taking the time today to listen to me and to learn more about IBM Predictive Analytics. Thank you.